So, friends, let us continue the discussion on the 14th lecture in module 2. We are discussing computer methods of estimating natural frequency and mode shapes. So far, in computer methods of estimating natural frequency and mode shapes are discussed. We have discussed classical eigensolver method, we have discussed influence coefficient method, we have discussed stored loss method. All are easily programmable. The solution is iterative and needs a algorithm to solve. Let us now discuss one more method, which is the fourth method, which is given by Rayleigh, which is again a numerical method which is easily programmable. Let us take an example to demonstrate this method. Let us take a problem which I am drawing here. Let us say this is 2k, this is k, this is m and this is 2m, and the degrees of freedom are this is x1, this is x2. We want to find omega and phi for the system. So, let us take Raleigh's method. It is again a tabular form numerical method. Let us say mass, deflection, which I call as phi r, which I call as m r, inertia force, which is alpha m r phi r, where units of omega square m are kept outside. Then we say computed deflection, which is a double prime of phi r. Then we say mode shape, which is phi r double prime. Then we say f I of phi r double prime. Then we also find m r phi r double prime square. Let us try to make a table. Enter these values. Let us say I want to enter mass m and 2m. These are the mass values. I assume the deflection with no zero crossing as 1 and 2, arbitrarily I assume this value. I take the deflections as the spring values which is mr phi r, which is alpha, omega square m is constant. Here mr phi r, which becomes 4 alpha, okay. Omega square and m are taken as constant. So, I make this sum, the sum is phi alpha, okay. I find this value is actually equal to this phi alpha divided by this stiffness, which is I write here as 2.5 alpha, and I will have a constant omega square m by k, okay, 2.5 alpha. By the same logic, I can say this will be 4 alpha by k, but the summation will be 2.5 plus 4, 6.5 alpha. Now, I take a multiplier A double prime as 2.5 alpha. Therefore, the mode shapes become 1 and 2.6. This 2.6 is nothing but 6.5 by 2.5. Okay. Once I do this, I will then find f I multiplied by phi r, which is simply alpha, and 4 alpha into 2.6, that gives me 10.4 alpha. I sum this up, I say 11.4 alpha. Then in the last column I find mr multiplied by phi r square. So, this is going to be simply 1. Here also I have omega square m constant, and here also I have omega square m constant, and this is going to be equal to 2m multiplied by 2.6 square. Okay, which is 13.52. So, I make the sum, this is 14.52 and so on. Now, I want to find omega. So, I get omega as sum of f I phi r, that is this column, divided by A double prime, which is this value, into sum of m r phi r square, that is this column. Okay. So, that is going to be equal to 11.4 alpha by 2.5 alpha into 14.52. So, if you substitute the units, you will see this value will be in omega square m, this value will be omega square m, they get cancelled, okay, they get cancelled, and this will be having a multiplier omega square m by k. So, I get omega square m by k. So, k by m will subside, okay, I can say that. This is omega square k by m. So, if you substitute that and take a root, I get omega as 0.56 root k by m, and the corresponding vector is 1 2.6, okay, that is this value. I started with 1 and 2, I got 1 and 2.6 non converging. So, one more iteration. So, again mass, deflection, inertia force, computed deflection, mode shape, inertia force multiplied by phi r, then mr multiplied by phi r square. Okay. Let us borrow those values. For my problem, this is m and this is 2m, and the previous iteration it is 1 and 2.6. I will take that value as 1 and 2.6. So, this is going to be alpha 5.2 alpha. I request you to follow the same algorithm what we expressed in the last cycle of iteration. Okay. Last cycle of iteration, the same way you get Fr, so you get Fi, then this is going to be this value divided by so let us take the sum, which is going to be (6.2) alpha. So, this is going to be 6.2 alpha by 2k. So, that is the stiffness. Okay. So, 2k, which is I think I should write 3.1 alpha, then I add them up, it becomes 8.3 alpha, and the sum. So, I take A double prime as 3.1 alpha, I get the mode shape as 1, and this is going to be equal to 8.3 alpha by 3.1 alpha, which is 2.68. Then this is Fi into phi r. So, phi r is this value, this is phi r 2. So, it is going to be alpha, this is 13.936 alpha. I make the sum, which is 14.936 alpha. So, this is mr into phi r square, which is going to be 1, and this is going to be 2m multiplied by 2.68 square, which is equal to 14.365. I make the sum, which is 15.365. So, now I find omega in the same algorithm. I should say phi I Fi phi a double prime divided by a double prime and this, which is going to be equal to 14 point omega square is 14.936 alpha divided by 3.1 alpha and 15.365, which will give me omega as 0.56 root k by m, and the corresponding vector is 1 2.68. I do the next iteration. I take this as m and 2m, I take 1 and 2.68, this is alpha, this is 5.36 alpha, sum becomes 6.36 alpha. So, this becomes 3.1 0.18 alpha, this is 8.54 alpha, and therefore, I take A prime as 3.18 alpha. I get mode shape as 1 and 2.69, that is my mode shape 1 and 2.69. Then you work out this value as alpha 14.418 alpha. I make the sum, which is 15.418 alpha, this is 1 and this is 14.472. I make the sum, it is 15.472. I got omega square as 15.418 alpha by 3.18 alpha multiplied by 15.472, which of k by m, which gives me 0.56 root k by m as omega, and phi is this value. So, we will believe that it has converged, and the final answer omega is 0.56 root k by m and phi is 1 and 2.69. Since there is no zero crossing, I can call this omega 1 and phi 1 respectively.